Enterprise software consulting has been sold by headcount for decades, but AI-augmented delivery just changed the economics of what a small team can actually build. Most consulting engagements are scoped in labor categories. A requirements phase staffed with business analysts, a development phase staffed with developers and a project manager, a testing phase staffed with QA engineers. Each phase adds bodies, and each body adds billable hours. The system optimizes for inputs because inputs are easier to measure than outcomes. But large teams create coordination overhead that directly competes with delivery. A 10-person team has 45 potential communication channels. A 3-person team has 3. AI-augmented consulting does not replace engineers. It changes the boundary of what a small team can credibly take on. Tasks that previously required dedicated staffing, like writing unit tests, generating documentation, and drafting requirements, can now be handled by the same engineers doing the core development work. This is not a marketing label for teams that use autocomplete. Genuine augmentation means AI is embedded in the pipeline as a structural component. The delivery model has 3 layers, and all 3 must be present. First is the judgment layer. This is human, architecture decisions, client context, and risk assessment. No AI tooling replaces the engineer who knows which abstractions hold up under production load. Second is the acceleration layer. This is AI. Code generation, test scaffolding, and boilerplate production. Third is the verification layer. Human plus AI. Code review, test validation, and audit trail generation. Without the judgment layer, you get fast garbage. Without the acceleration layer, you get slow correctness. Without the verification layer, you get unauditable risk. An AI-augmented delivery team for enterprise custom development looks nothing like a traditional staffing plan. Instead of 10 to 12 people, you have 3. A lead architect, a mid-level developer, and a QA and documentation specialist. Take a real scenario. A developer on a small consulting team is strong on back-end logic, but struggles with front-end unit testing for React components. In a traditional model, you add a QA engineer to the team or accept thin test coverage. In the AI-augmented model, the developer describes the component behavior, and the AI generates the test harness. The developer reviews the generated tests, adjusts for business logic, and runs them. Test coverage goes from 15% to 80% without adding a person to the team. The skill gap did not require a hire. It required tooling. But there are common failure modes. The most common is treating AI interaction as an ad hoc skill rather than an engineered system. A developer who writes good prompts in a chat window is not operating an AI-augmented pipeline. Disciplined AI augmentation requires persistent context, like maintaining project-level configurations that provide the AI with architectural standards. Another failure mode is skipping the verification layer. AI-generated code can be syntactically correct but architecturally wrong. Every line of AI-generated code must pass the same quality gate as human-written code. Finally, using AI for delivery speed without using it for institutional memory is a massive missed opportunity. AI-generated documentation, decision logs, and dev journals are nearly free to produce. Every engagement ends, and every team transitions. The question is whether the institutional knowledge survives in a queryable format or walks out the door with the departing contractor. AI-augmented consulting is not about replacing developers with AI. It is about restructuring delivery so that experienced engineers spend their time on judgment and architecture, while AI handles the repetitive, parallelizable work that traditionally consumed the majority of a team's capacity. The consulting model is finally shifting from selling hours to delivering actual capability.